Hi everyone, we are going to be talking about temperature and heat. So let's start with the difference between the two. Heat is the flow of energy from one object to another that's caused by a difference in temperature. And along with that, heat transfer is the movement of energy from one place to another or one material to another. Temperature, on the other hand, is the quantity that's measured with a thermometer, and it reflects the mechanical energy of particles in the system. So, more temperature means there's more mechanical energy. Thermal equilibrium is the condition in which heat no longer flows between two objects that are in contact, and the two objects will have the same temperature. So we need to talk about the zeroth law of thermodynamics that states if two objects are in thermal equilibrium and a third object is in thermal equilibrium with one of those objects, it's also in thermal equilibrium with the other object. So if we look at this diagram here, or this image, we have two boxes, B and C, that are in contact with each other. They're not moving, and they are in thermal equilibrium. If I bring in a thermometer called A that touches B and it reads some temperature, these two, A and B, are now in thermal equilibrium as well. We can also bring A to box C and read the temperature again, and it'll have the same temperature reading as before, and A and C are in thermal equilibrium, meaning A, B, and C are all in thermal equilibrium with each other. Let's look at types of thermometers. The first being the most common that we have all probably at least seen or heard of. It is a alcohol glass thermometer that has red dye in it, and this red dye will read you the temperature. Now this is what has replaced the classic mercury thermometers back in the day that we no longer use in um, lab or anything due to mercury exposure. The second is a plastic or liquid crystal thermometer that contains a film that is heat sensitive. So you can see she's holding it up to her forehead to read her temperature. Then we have another one that measures infrared radiation to produce a temperature readout, and that is a pyrometer. Okay, and this is what we have been seeing in the recent years with COVID-19, and we have used these maybe in the doctor's office or even in the classroom. I know we were using those to check temperatures of people's foreheads to try to prevent spreading of anything. So this is definitely relevant to us. Now let's take a look at the temperature scales. So the temperature scales are important to see the differences between the three. So we have one at the top, degrees Fahrenheit, which we all know and use in at least America, USA. USA uses this. And we use it, and it's very different from, I would say, most of the rest of the world. I'm going to say most of world uses degrees Celsius. So why is this important to point out? Well, because sometimes we are trying to talk about something in everyday life, maybe, the weather, and we say it's 75 degrees. 75 degrees Fahrenheit is very normal. 75 degrees Celsius is very abnormal. So that would be very, very hot in temperature. If we were talking about degrees Celsius. So the weather probably isn't that. So we need to know how to at least recognize and then convert between those two temperature scales. Notice another thing. If we're looking at the body temperature of a human, the quote unquote normal body temperature, we use Fahrenheit, and we say it's 98.6 degrees Fahrenheit. Now, in Celsius, that is about 37 degrees Celsius. There's another scale that we need to talk about, and that is Kelvin. So this is Kelvin. And on the Kelvin scale, the normal body temperature would be 310.15 Kelvin. Notice that I'm saying 310 Kelvin and not 310 degrees Kelvin. Okay, there is no degree sign, so it's just Kelvin. So who uses Kelvin? Well, the scientific community uses Kelvin. And why is that? So let's go back a second and think about how we came up with, say, degrees Celsius, for example. We came up with degrees Celsius by saying that the freezing point of water is 0 degrees Celsius. So we said 0 is our low point, and that's where water freezes. So that is a freezing point. Okay, well, we found out that it can get even colder, and even so cold, theoretically, to some absolute zero, which would be here. That is at 0 Kelvin, or 0 K. Now, at this 0 Kelvin, or absolute zero, we would theoretically have no movement of atoms, molecules, anything. And so that is something that is very hard to do, and why it is still theoretical. This is a theoretical absolute zero because we haven't been able to get down to that point yet. So we haven't been able to reach 0 Kelvin. We have come close within a few kelvins, but not all the way down there. So this is still, theoretical because it's very hard to stop every single atom from moving and creating energy and therefore heat, and so we have a temperature. Okay. So why is it important to, talk about these different scales? Well, we need to be able to convert between them all, since a lot of times, maybe here in the USA or most of the rest of the world, we will measure something with a thermometer, and the thermometer will give us a reading in either degrees Fahrenheit or degrees Celsius. And so we need to get those values and be able to convert to Kelvin in order to make our scientific calculations based on that unit. So kelvins is also an SI unit. Okay, so this is a standard unit that the science community uses, much like meters, much like kilograms, and so forth. All right, so here is a chart converting between the temperature scales. So we have what we're converting and then the equation on the right-hand side. So if we're, say, converting from Celsius to Fahrenheit, this is the equation that you'll use on the top there. And I'm not going to go through each of them. They are here for you, and we will be using them. So just make sure to pay attention to what we are given and what we are looking for, what we're going to do with that temperature. Okay. All right, so I'm going to pause here and then we will pick up on thermal expansion in the next one.